All right, so let's get a brief feel of the room here. How many of you are back-end guys? Okay, that's like halvesies. How many of you are front-end guys? That's like 75%. What are the rest of you? All right.
I pretend to be both. Does that count?
That's good. I like that. Who feels like they're a newbie? We got, okay, good. Not too many newbies. Great. Well, that makes it easier for me because I use big words and it's hard and life is hard, you know? So the original title of my talk was Let's Encrypt, but that makes it sound like it's way too much about the technology that's also called Let's Encrypt, which I am going to talk about. So instead, I retitled it Let's Secure. And getting pwned is lame. So I'm AJ, also cool AJ86, also guy with the hat, right? And I work with Bryson. We are co-founders of Daply. And like you probably saw this morning, we are manufacturing a device cloud. And security is a really important focus to us because, well, I mean, like privacy is important. And if you're going to put a device in people's homes that could potentially have access to locks, backups of hard drives, you know, lots of important things, it's very important that applications that end up on that device are secured both by the device itself as well as by the developer. And so it's been a particular area of interest. Also, before this, we were working on another project called LDSIO, and we were making a rogue API wrapper around LDS.org. And that actually got far enough that it caused some ripples at the church, and they supposedly have created a department that maybe 9 months from now we'll find out whether or not they successfully repeat what we did, but they were supposedly doing that. So I'm gonna start off with one notion because this encapsulates so much. SPAs, anybody not know what that means? Anybody does know what that means? Okay, SPA is single page application. So that's Ember, Angular, a lot of React, a Backbone, Marionette, like these types of applications that they don't necessarily have to be just one page, but the idea of having your app in JavaScript is a really, really good idea. There's a lot of security problems that just like go away when you're using Angular, for example. After that, and this is, I'm just going to go back and forth. I'm a little bit scatterbrained, I'm sorry, but you ask me questions. If anything doesn't flow right or you're confused how things connect, feel free to butt in. But I want to start off with, have I been pwned? So if you have a laptop or a phone or something, I want you to go to haveibeenpwned.com real quick and type in your email address.
Do I trust you?
Well, I mean, like the only piece of information you're giving up is your email address, right? But just go there real quick, type in your email address, and I expect that about 75% of you will find that you've been pwned. That means that some leak has occurred where your email address and other information about you has made it public online, possibly your password. I know that I had to change my eBay password like 6 months ago, and I'm imagining that it was related to one of those breaks of like huge major sites that's been happening, you know, over the past 2 years. So is anybody got a hit? Anybody been pwned? Yep. Okay, is anybody who's checking not been pwned? Okay, so it looks about half and half there then. But the answer is yes, you have. Like whether or not it's showing up there, you've been pwned. So it's kind of a trick question. So some cool, fun things, and this is only like half of the list. You know, you that are seeing the site, you see the list goes on and on and on. If you created an account with Adobe because you had the Adobe suite before 2011 or something, every account was compromised. Like every account in Adobe's database, the whole database was downloaded. So everybody that had an account with Adobe before 2012 or 2011 or whatever the attack was, luckily they were using some encryption. That encryption is relatively weak, or so the report says. And a lot of the passwords were duplicates. So there's literally tens of thousands of accounts for which they know the password. But a lot of them were stupid things like password and ABC123 and stuff like that, right? But so Adobe, Snapchat, 4 million accounts, Forbes. A lot of you probably read Forbes online. Might have, you know, you get sick and tired of that, like, sign up and follow us, sign up and follow, and you signed up and you used some password that you used somewhere else, and that's been compromised. If you've traveled in Europe, you may have used Vodafone. That's one of the cell carriers there, like Verizon is over here. And then, of course, Sony had that recent breach with the PlayStation Network, 37,000 accounts. What's that?
Ashley Madison.
Oh yeah. Did I?
It's up there, the second one.
Yeah, I guess I just thinking like people in this room probably aren't like necessarily heavy users of that. I mean, I'm hoping. But yeah, Ashley Madison, that's the most recent one. That's pretty big. 30 million politicians that have too much time on their hands. All right. And so just in case you're wondering, these are the most common passwords. Obviously, you're not using those passwords, but one of your coworkers is, so they've been pwned. Yeah, so this was from the Adobe database, so a lot of the passwords were like specific to Creative Suite. I'm sure you've done that too. You've logged into a site and you've used a dummy password that's like the name of the product of the site, right? And then there's a site called SSL Labs that will tell you how secure, it'll rate the certificates of a particular website, whether they're using strong encryption, if the certificates are up to date, lots of different metrics. And if you visit that site at any random moment, it shows you who's most recently run a check on their system. If you run, I highly recommend if you have a web server, you need to have SSL. If you don't, you're doing it wrong. And by SSL, I mean TLS, because no one uses SSL anymore. But we'll call it that for the next couple of decades, just like we call ECMAScript JavaScript. So at any given moment, it will show you a list of sites that have just been checked, and then like the sites that have done the best most recently and the sites that have done the worst most recently. And lo and behold, singlesignon.cisco.com gets an F. Cloud singlesignon.cisco.com gets an F. Okay, that's today, right? So if someone were snooping on your Cisco single sign-ons, an F means that they're using very poor encryption that would take, or either invalid certificates or very poor encryption that would take not astronomical amounts of time to break. So, for example, might be able to be broken within a matter of days or months. So these are just like a couple of points of failure. So I want to talk about points of failure, like where security fails. And these are kind of like big, huge topics that we can go into, well, we will go into more and maybe even, well, yeah, and also look at some code for them. But TMI is a big one. What's an example of TMI?
Just giving out more than is needed.
Right. So what is it that you need from your users? And what is it that you're taking? Because if you're taking something you don't need, then you're setting yourself up for failure, right? Transit, like this is typically HTTPS. We want to encrypt things during transit. We don't want something, between my laptop and my bank account. I don't want someone to be able to either over the air, be able to capture some packets. And by the way, you guys know that there is no security in Wi-Fi, WPA, PSK, TKIP, whatever, right? Like, what the Wi-Fi encryption does is just guarantees you an Ethernet level of security. So like if I plug into the wall with Ethernet, there is no security, right? Everybody that's on the Wi-Fi network is, they're all susceptible to each other. So there's different layers of transit and encryption in transit. There's storage, because I can take something encrypted in transit, but then if I store it unencrypted or I store it in an unsafe way, and I guess I should, and to the next point, somewhere in between these, I need to address physical security as well. Infrastructure, I guess maybe physical security could go in with that. Yeah, physical security could go in with infrastructure. Infrastructure is like things that you own. Things that you physically own, like that are part of your office, part of your computer that you work on, part of the computer that you're developing, that your code is deployed to. Dependencies, things that you don't own that you choose to rely on. And then the browser. The browser is really number one. Like the browser is just terrible. It's an absolutely horrific story. The whole internet is just a bad story. I mean, a couple of guys sat down in a university and theorized about what if some computers could connect together, and then they started sending email where the only fields in the email that provided any sort of identity were the to and from. And I mean, did anybody in high school, you sent a message to your teacher from the principal? Did anybody do that? Am I the only one? No, oh, come on now. Be honest. Be honest. Somebody's done it before. Somebody's done email spoofing. You've spoofed your friend. All right, come on. Thank you. Huh?
Not that specific scenario.
Okay, yeah, but you've spoofed email. So I mean, like, that's the whole history of the internet is like, oh, cool, we can do this. And then before you even know what's going on or you can create a proper standard for it, you've got 8 billion people on the planet that are using it, and it's too late to go back. So it's just the browser and the internet are just terrible stories. So let's talk about TMI for a minute. There's one thing that immediately jumps to my mind that I almost guarantee will not jump to your mind. But I do want to hear some thoughts. Like, what are things that websites collect from you that they don't need to collect from you? Or things that you're collecting that you think maybe you don't need to? Yeah, I don't know why that is. It doesn't make any sense. Like, unless they're running your credit, they don't need that. Yeah, it's so weird because they want a unique identifier for you, right? And so yeah, totally bad news.
Age.
Okay. Yeah, I'm not specifically too worried about my age in terms of my privacy, but
No, but
what?
it's too much information.
Yeah, yeah.
They show you ads based on it. Like I always say, teenage girls, because that's the kind of ads I want.
Yeah. Yeah, totally.
I don't like My Little Pony ads. I don't want
No, I see what you're saying, because like teenage girls, they don't get porn ads, but
Correct.
but single men do.
That's right. That's why I always say I'm a teenage girl.
That's really smart. And you won't like get any ads about pregnancy tests or anything either. So I mean, that's a really non-awkward way to go. Yeah, I like that. There's something over here.
Email address.
Email address. I don't know. That seems kind of normal. Why do you say that?
Well, I mean, I guess some sites need it, but if you don't need it, then they all get stolen. So I don't know exactly so
Okay. Yeah.
I would agree with that. It seems like every site I create an account, they ask me for my email. Even when I download an app, suddenly I'm getting an email from an app that I downloaded on the iPhone. It doesn't make any sense.
Yeah, it's kind of interesting. I mean, to the point of email, I think there's one intrinsic value there that's very nice, which is that you have a point of recovery for an account. Although, what I'm going to say, like, number one, yeah, there's side note here. Best way to keep a secret, don't ever know it, right? That's what we're talking about. Too much information. We don't like that. I would say the number one piece of information that sites collect about you that they ought not to is your password. Because like most sites, I mean, like all the sites that you guys run, like you're not doing the right stuff with passwords. You're not decrypting them. You're not you're not. Like it's just, you're not doing it right. Like just admit it. Like we don't even know what the right way to store a password is because they just always get leaked somehow. But like you can delegate. You can use something like OAuth 2 or OpenID Connect, and there's something recent that's kind of cool. Keyboot, that one of the big Node guys, Substack, he basically created a kind of system that's like OAuth 2 and OpenID Connect, but it's between browser tabs. So your encryption key gets stored in the browser. And that's actually something that Bryson and I are working on with our OAuth 3 spec that we're also going rogue on and creating without any like blessing from the OAuth people. I'm going to grab the SEO before they do. But so there's these, like honestly, Facebook, I would think that Facebook is probably more secure in terms of their keeping of your secrets, your password, than your bank. Like I totally do not trust my bank with my password because I can only be between 6 and 8 characters, and I have to have one of those characters as a number, and one of them has to be special. I mean, like, has anybody ever signed up for an American Express account? They just recently, last year, I think it was, bumped it so you could have up to 12 characters in your password. So, I mean, that's nice.
You know, Vanguard's security questions, they have a nice little feature, so if you make a typo in your answer, they'll still let you into your account. That's actually still an estimate.
Oh, yeah, and those security questions are amazing. Like, what was the name of your favorite pet? What city did you grow up in? What can I Google about you and know?
I have a mortgage, and like the online site like wouldn't let me put like symbols in my password or something.
Yeah, it's crazy. So I mean, people just do passwords wrong, but more than that, let me see. I think that's on the next slide. Maybe it's not. Okay, yeah. So like one way to avoid this problem of passwords is like seriously just like trust someone that's better than you. And the other way is still, don't ever know the user's password. So even with bcrypt and stuff, Heartbleed, right? Heartbleed affected, and I don't think it was as big as they made it out to be because there was only so many Linux boxes that were running 1.0.1c. What?
I'm wearing a Heartbleed shirt. They made shirts about it.
Yeah. So Heartbleed was this vulnerability in is lib OpenSSL, I think it is, right? Anyway, there was a couple specific versions where they forgot to zero out a value after they allocated it, which is another reason that software developers should not be using hardware languages. C is for writing drivers for devices, physical things. C is not for writing software. Just throwing that out there. If you're writing software as an application, don't use languages that require you to manage memory. Anyway, they didn't zero out this particular buffer, and then it would send memory across the wire, just random bits of memory. And if you all day long hit the server with a special SSL packet, it would respond with what was supposed to be random data, but turned out to be data from your RAM. And then if they did that all day long, they could actually reconstruct what was in RAM and then retrieve private information that was in memory, such as passwords that hadn't been overwritten by other memory yet, and encryption keys, that sort of thing. So there's also this concept of a proof of secret or a secure remote password. I prefer this term. I heard it first, but this seems to be the buzzword that's gaining more traction right now, SRP. And the proof of secret is basically this idea that you actually don't let the person's password leave the browser. So we now have web crypto, and web crypto, I am so thankful, will not work unless you have HTTPS turned on. So hurrah to the standard makers for forcing you to do something in order to get a benefit. I'm very excited about that. And also hurrah to standards makers for making HTTPS now free, as we'll talk about shortly. But a proof of secret is this idea that you take the password in the browser where you have not touched it. That's happening on the memory on the laptop of the person that is using it. You take some sort of salt, some sort of differentiator, and in the case of being in the browser, it's probably something that would really be publicly available. Like you could use the user's username, or you could use a value that you've stored and then you retrieve. The goal is not for this salt to be secret. The goal is simply that by using a salt, you guarantee that any attacker has to create a table for that specific user. So it doesn't matter in this particular case that the salt is unpredictable or cryptographically random. It could be, but you could literally just take their email address and use that as part of the salt, and it would be sufficient for the purpose of slowing down an attacker and making each account attack unique. And then you have some sort of algorithm. As far as my experience goes, the most secure algorithm is called Scrypt, and then bcrypt follows that, and then pbkdf2 follows that. However, if you're considering this kind of strategy, you have to consider that the differentiator is going to be shared between your mobile app, your Android app, your iOS app, etc. So pbkdf2 is kind of the common denominator that's going to be the easiest for you to deploy across many different environments. Something like Scrypt has a couple of advantages because where many hashing algorithms, anybody familiar with Bitcoin, you've heard of it at least? It's got this thing called a blockchain, and everybody talks about gigahashes. So some algorithms like pbkdf2 and bcrypt can be done with gigahash software or gigahash hardware, where somebody can load it on a GPU and do it thousands or millions or billions of times faster. Whereas Scrypt, I don't know exactly what the details are, but they claim that you can't create a hardware accelerator for Scrypt. So just some thoughts to know. So anyway, you've got the person's password, you've got some differentiator, some salt that you share among applications that the user has. You pick an algorithm that you like. One of those three is probably the right one. And then you end up with a proof. And that is the proof of the secret. So you never have to take the user's password. You never have to know it. You send that proof to your server. And when it gets there, you do the same thing that you should be doing already. You use, again, pbkdf2, Scrypt, bcrypt, one of those. You do the same process again. And now, not only do you not know what their password is, but you're not even storing what you do know. You're storing a derivative of what you know. And so think about that, not just for secrets, but for any type of information that only needs to be used as an identifier. If you don't need the person's email address, if you don't actually need it, you could use this process. Whoops. You could use this process on their email address and be able to still log them in, but never actually have their email address. So this is kind of a neat way to get around TMI in any situation. If you only need something as an identifier or as a check. Any questions about that? Yes?
How do you know they're using a strong password on the client side? Like let's say they choose password as their password. If they send it to you as a pre-hashed thing, you don't know if they use the weak password.
Yeah, so that's like a super good question. That would happen on the client side. So if they were technical and they're like, man, I really want to create a dumb password for this site, then they could go into the console, or they could like spy on the connection between their iPhone and their router. So
It's in JavaScript, so they can just do whatever they want.
yeah, but I mean, like,
They go to the effort to do that so they can have an insecure password. Not anybody.
yeah,
It's
so
their own fault at that point.
Yeah, there's problems with if you as an organization need to say we know that there's a complex password, then you can't go in and prove that it was a complex password.
that's true. It's a valid point. I've thought about that too, and my conclusion has just been, well, if they're a developer and they're hacking their own account, let it be. Over here? All right. So that's one thing down. Oh, and so I'll share these slides with you guys. I have some links to a PBKDF2 demo that works with a couple different libraries in the browser and also in Node. So there's web crypto, and then there's some things that have existed before web crypto. And I have a blog article. It's called Secure User Passwords from the Browser On. It's similar to some other articles, and I'll just show you a demo. Well, or I won't, actually, because I clicked on it and it didn't work. But I have this little form where you can type it in and you can click some buttons and you can see the result of what would actually get sent to the server, that kind of thing. So transit is another interesting topic. And I put here first party, second party, third party. When you think of encryption, you'll have to, like encryption and transit, you also have to consider the whole PIPA, SOPA, CISA, SIPA, PISA, like all those things, right? Because you have a secure connection with Facebook, right? But what is my goal? Like, do I want to communicate with Facebook? Is the reason I'm using Facebook to communicate with Facebook? No. The reason I'm using Facebook is because I want to communicate with Bryson, or I want to communicate with Chad, or maybe I want to do a voice call with Matt. You know, that's why I use Facebook. And so consider in transit, like you have these third parties that don't play by your rules necessarily. They don't necessarily play by the government rules. They don't necessarily play by their legal rules. They may say one thing and they may do another. So when you consider the transit mechanism like SSL, HTTPS, TLS, consider whether the party that you're communicating with has it in your best interest to keep that communication private. Because it doesn't matter if you encrypt your connection to Facebook when somebody else is tapping in on the inside, which, I mean, it's happened. If you haven't seen Mozilla and the EFF have this video that they promote called Terms and Conditions, and they go through like tons of documented cases of where social infrastructure companies have abused user agreements and gone against the user's privacy. So again, I'm not a tinfoil hat guy, but this stuff is real, right? So first party, second party is like me to you, direct. When you get into third party, transit doesn't really mean as much. I was mentioning earlier, there's SSLLabs.com. If you want to check out, everybody in this room, if you haven't run a test against your server, you need to do this. Because likely what's happened is that you've set up your server with some default settings. You're using Ubuntu 12.04. You got the latest security patches when you set it up a year ago. And since then, 1024-bit keys are no longer considered safe. Certain encryption algorithms are no longer considered safe. And so you actually need to go back in and update Apache or Nginx. And in some cases, you need to edit the configuration file to tell it, hey, don't use this type of encryption or do use this type of encryption. In most cases, just sudo apt-get upgrade is gonna do you wonders. And if you just do that and then run the test again, you'll see you went from a B to an A. But just something to keep in mind. And I promise I will get to some JavaScript. I know I'm talking a lot of like system level, but it's all over the place, right? And just to give you an idea, and I'm not going to explain this completely correct, but just to give you an idea of how HTTPS works, there's two mechanisms in it, and this is how most communication encryptions work. And I'm just going to simplify it with only mentioning three things that are the most common. So RSA and DH are mechanisms by which we have some public part and some private part, and we exchange information. So like I go to my bank sends me a public key. I use that public key to encrypt a very small amount of information. I'm going to choose a secret key, and I'm going to send it back to my bank. And that's the asymmetric operation. The bank gives me a public key. I encrypt with the public key. I send it back to the bank. From there on out, this is a slow process, and it can only be done with very small amounts of data, like 4,096 bits of data. So, you know, like a couple sentences. You can't realistically send more than a text message with RSA or Diffie-Hellman type encryption. So don't worry about like exactly what that is. Just get the picture that public private parts, small message, slow connection time, but then once it goes through, you continue with a symmetric encryption, and the most popular type is AES. AES CBC 128. There's no reason to go above 128 encryption. This is super technical, but just to know, there's all the stuff about 256 being more secure, and it's all baloney. There's actually, for very technical mathematical reasons, the way that they expand the bit entropy in 256-bit algorithm for AES actually makes it almost as weak as 128. And you can research that. Bruce Schneider is the thing to Google. He'll tell you all about it. But this symmetric encryption is very, very fast encryption. It's basically just flipping some bits. It's like a Caesar cipher. It's like your little Annie ring, right? Where you turn it to the right thing and it just like, you'd spit it out super fast. Obviously, your computer's not using a Caesar cipher, but you can think of symmetric encryption that way, where it's like really fast and the computer can figure it out, but humans can't. So just so you know, it's a two-step process. If you were to download, like with wget or curl, if you were to download an image over and over again from an HTTPS site, you would get different bits across the wire every single time, because every single time the session, which is the symmetric part, would be a new cryptographically random piece. So Let's Encrypt. How many people have heard of Let's Encrypt? Yes! That's awesome. So Let's Encrypt, I was going to do like a way cool demo with them, but they switched their launch date from September 15th to November 16th, so I don't have the luxury of doing that with you. However, this is how you're going to get free SSL certificates. It's a super simple process. You sudo apt-get install Let's Encrypt, or yum, sudo yum install, whatever you're using for package management on a server, or have your administrator do that for you. But all they got to do is install the client, provide an email address, a domain name, and the domain has to point to that server, that DigitalOcean box, that box in your living room, that box in your office, whatever it is. It does a check. It does exactly what we were talking about before. It does a little bit of asymmetric and symmetric exchange back and forth to verify that the server that is pretending to be such domain, example.com, actually is, and then it issues the certificates for free. So until then, you can pay $10 at name.com, and they have a super simple process for getting certificates, and I've got a video tutorial that's like step by step. So if you go to coolaj6.com and look for stuff about HTTPS, you'll find a couple tutorials there. Super simple process, takes 5 minutes. If you're not using encryption and you have to wait it out, start using it when November 16th comes. Yeah, this is what the command looks like for that. Super simple. And then in your directory structure, you end up with some keys like this. And just to gloss over this idea, I was talking about how HTTPS, like if I'm talking to Facebook, like I'm not actually secure in talking to Bryson, because Facebook's intercepting that data, it's decrypting it, it's doing something with it, some analytics, maybe something naughty, maybe something nice, I don't know, right? GPGP is encryption that you can send through third parties, and none of the parties that handle the message are decrypting it. So I'm not going to go too deep into that, other than to say that there is a website, 2 websites that are employing this technology in the browser, and if you're interested in that, if it perks your interest, keybase.io, scramble.io, check them out. They have repositories on GitHub with all of the hard work that they've done over the past several years, and you can use their libraries to have encrypted conversations through untrusted parties.
Is that misspelled scramble?
It is Scramble, sorry, I misspelled it. Yeah, it's scramble.io. And this kind of goes, you don't want to layer encryption on top of encryption on top of encryption, because it will slow things down marginally, and in some cases, perhaps more than marginally. But just keep in mind that security doesn't exist where you think it does. Always consider the parties that are involved that the communication needs to be secured for, because for some of you, this might be the right solution. So let's talk a little bit about storage.
You're out of time, so.
I'm out of time, dang. All right, well, let me see if there's any couple of things I really wanted to say. Okay, there's a couple things that, is somebody else coming in? Well, okay.
It was awesome.
All right, well, this is really important, so I'm going to tell you anyway. Never concatenate strings. Don't do it, ever. That's SQL injection. That's cross-site scripting injection. Don't ever concatenate strings. If you ever got tempted to put like plus with strings and a variable in the middle, don't do it. It's bad. Don't render HTML. Don't use www form URL encoded. Use JSON when you're doing posts. Don't use cookies. That's impossible to avoid. Like every single library is written with cookies like to the core, expecting you to use them. But if you can't avoid them, don't use cookies. Try to use something like tokens instead. So don't use string concatenation. Use templates. Don't render HTML. Send JSON. Don't use URL encoded forms. Post JSON. Don't use cookies. Do JWT or tokens like OAuth tokens. Or use subdomains where you need a cookie. Like you subdomain some assets that need a cookie with a certain API that needs a cookie. And then a bunch of buzzword stuff. Yeah, we'll just go with that.